Okay? We're going to move on to one more step, that once you know your empirical formula, are you actually able to determine a molecular formula from that? And the answer is actually yes. One thing you have to have is you actually have to have the molar mass of your empirical formula. Now, in a laboratory setting, a lot of times you can find percent compositions and you can find overall molar masses by using different techniques within a lab. By using those two things, you can put it together and actually solve for your overall formula for that substance. To do that, your first step is to identify the empirical formula. So for example, we've done that on the board here. We know our empirical formula. Calculate the molar mass of the empirical formula. Okay. Look up the actual molar mass of your substance. That might be by doing a lab procedure or using an actual lab manual, something that gives you that information. Divide the two, and once you divide them, you find your multiplier. That multiplier then can be used to multiply the subscripts to find your actual formula or molecular formula. So let's use the example that I started with on the board, and we'll use that to kind of find a molecular formula. Okay, so I've cleaned up our work, and all I have right now is our answer from our previous practice problem, where we ended up with an empirical formula of 6 to 6 to 1.5 to 1, and we had to multiply it times 2 to get the true empirical formula for our organic compound as such. From this, if we had the molar mass of the whole compound, either by given to us in a word problem or solving it from lab data, we could actually solve for the molecular formula. So let's assume for this that the molar mass of the true compound is 697 grams per mole, measured out to, let's say, 3 sig figs. So the molar mass of this compound is 697 grams per mole. Okay? Our job now is to figure out what is that molecular formula, or what are these values for this mass. To do that, we need to find the molar mass of the empirical. Okay? So we need this value here. What is the molar mass of the empirical formula? Well, we can do that because we know the amounts for each one. So we can say for carbon we have 12, for hydrogen we have 12, for oxygen 3, for nitrogen 2. Take that times their atomic masses. So if we take these times their atomic masses and then we add them up, that will tell us our empirical formula. So 12 times 12.01 gives us 144.12 grams per mole. 12 times 1.01 gives us 12.12 grams per mole. 3 times 16 is 48 grams per mole. And 2 times 14.01 is 28.02 grams per mole. Now I'm going to add all these together. So if I add them all together, I get a total of 232.26 grams per mole. Okay? So the molar mass of my empirical formula is 232.26 grams per mole. Here's the actual molar mass. Here's what the empirical formula is. Take your actual molar mass divided by the empirical. So if we take the 697 divided by that, 697 divided by our 232.26. And I get a number that comes out to be almost exactly 3. It's actually 3.00094772. So I get a number that says that this number is 3 times bigger than this number. So if this number is 3 times bigger than this number, that means my formula, the actual molecular formula, is 3 times bigger. So here's my multiplier. I use that now to multiply in to each one of these values here. So to find the actual molecular formula of this, I'm going to erase this. I take 12 times 3, so my carbons are 36. 12 times 3, so my hydrogens are 36. 3 times 3, my oxygens are 9. And 2 times 3, my nitrogens are 6. So this would be the molecular formula for this compound. Okay? You must start with a known empirical formula. You have to know the molar mass of the actual compound. Okay? This is going to be given to you. So this will be most likely a given value. This you most likely will have to calculate. So once you know this and you know this, you solve for the molar mass of your empirical formula by doing this, which this value then, take the known divided by the empirical, get your multiplier, multiply them out, and then you find your final answer, which is the molecular formula of your substance. Alright guys, we will do some more practice with this in class, but that is empirical and molecular formulas. Thank you.